Hi. So we are going to speak about the framework we build to monitor our telecom network. So all the threats linked to telecom networks. So we are part of Post Luxembourg, which is the main operator in Luxembourg. And I was mainly a telecom security researcher, doing a lot of attack. So offensive telecom security, and now I'm doing more and more defense as I need to defend my operator and my colleague.
Hello, everyone, and thanks very much for staying with us until this late. Really appreciate that. And my name is Keung Nguyen. I got my PhD like 8 years ago. I was working on the academia, and recently I joined Post as a security data scientist, and I have a background in machine learning and software engineering. And as you can see, what I can bring to the to this work.
So why are we there? Mainly because there is a lot of fraudsters trying to get money from our telecom network. You have a lot of states, a lot of criminals trying to get call interception, location of subscribers. So everything that could harm a subscriber or even the infrastructure has a real interest for us. And the main issue with operator, it's since 30 years we were stacking technologies. So we have been stacking 2G, 3G, all the fixed line, now fiber, all the technologies, we are stacking it, and we are not so much removing technology. So we have to keep up with all technologies without any security, that have been built without any security. So what we did is we are now trying to build a framework to monitor all these technologies. And the goal is mainly to monitor for frauds, location tracking, interceptions, attack on our infrastructure. And for this, we are covering technologies linked to SS7, which is signaling protocols for 2G, 3G, GTP, which is carrying your data over 2G, 3G, and 4G, and diameter, which is replacing SS7 on the 4G network. And so this, so just before, so the goal of the framework, it's mainly to have protocol decoders, and after that, put everything in Splunk. But I will go further on that later. So we will focus the whole talk on diameter. So the 4G part, mainly because diameter, it's the protocol that will be handling 4G, but also now 5G, but on all the evolutions on 4G. So what you have to know, it's that, so you have your antenna on the left, the MME is carrying all the signaling, so understanding your authentication, the change of location between antennas. The low-level serving gateway and PDN gateway are handling your traffic data to internet, and the HSS, it's the main database where you have all the keys, cryptographical keys, and the profiles of the subscribers. These HSS and MMEs are connected to the IPX network, which is the global roaming network for operators. So all the operators obviously are interconnected because you are doing roaming. So to be able to do roaming, as your SIM card needs to be authenticated, you need, when you are, for example, with my Luxembourgish SIM card, I'm going to France, my Luxembourgish SIM card needs to authenticate itself to the HSS in Luxembourg, because only the HSS in Luxembourg has the keys. So just quick overview of diameter. It's carried over STP, defined by an RFC for the headers, and all the AVPs, it's like radius, all the AVPs that you have, you can have plenty of AVPs containing all your information, and these are usually defined by the 3GPP because they are telecom specific. So the actual setup, what we did, it's, so we have two DEAs, which are diameter routers, okay? So it's the edge of our network to the international network, interconnecting us to all the other operators. And so we are tapping the traffic, so the live traffic of these two nodes. So everything passing from international to the internal network, and from internal to international. And we are decoding it in live, in real time, and sending this to Splunk. We choose just Splunk because it was already deployed on the network, but you could put ELK, you could put any other CM. Because so what we are doing is we are parsing the traffic, extracting the fields we want, and outputting this in JSON format. So it's really easy to read. We can have any tool reading it to parse, not complicated. And I'm getting two types of information from my decoders. One, it's I want to see everything. So because I want to be able to analyze later everything that was going on my network, because I can have some ideas or I can do forensic later. And I have also implemented some really basic detectors for attacks that I already know. For example, all the location tracking, any DOS, or a real targeted attacks that I already identify signatures. This I can easily get alerts without having Splunk to analyze anything. But still, the goal is to minimize the effort on the decoders, to just keep decoding traffic, and Splunk that will do the stateful and all the intelligence. And why building it? Obviously, because we want to be proactive, so we want to detect as soon as possible any attack on the network. Even if we are blocking a lot of attacks, you want to see the ones that will pass, or even you want to see the ones that will be blocked to have the knowledge of who is trying to attack your network.
Yeah, so just to add some small information regarding that. So we want to protect not only our infrastructure, but also to protect our subscriber. So if we receive like massive spamming SMS or spamming call, we try to block them as soon as possible.
And so these attacks have been presented in other talks, so I will not spend too much time on it. But mainly what I want to defend against, since I only allowed from international the S6A family of diameter messages, all the other attacks, I don't have them anymore because I'm just dropping them at the entry of my networks, but I'm still accepting all the other messages. And these messages are obviously carrying attacks, and I want to be able to detect them and obviously block them. So mainly the first step is to know who is on your network. So you need to understand what is going on your network. So you just take 1 week of logs and you try to understand what is going on. So as you can see, from Monday to Sunday, when you are starting the day, you are always have like a small peak, at noon the same, and at like 5, another peak. And the thing is, people are coming in the morning. When they are going to lunch, they are taking their phone, and when they are leaving the office, it's exactly the same. And they are doing it every day, but the last peak, as you see, it's like increasing on Tuesday and Friday, because obviously there is after works, so they are staying more and more after the job. And in the weekend, they are not waking up so early, so you have only 2 peaks on the weekends. So you could think that, okay, it's just normal people, but for us, when you see this, and since it's like continuously the whole year, like people are really predictive. So we are like robots using our phones always the same way. So this is like quite interesting for us, because when you want to do behavior analytics, this part is really interesting to understand what is going on your network. So what we are monitoring actually, we are monitoring all these attacks, but some of them we are not monitoring the attacks targeting inbound roamers. So this means that all the roamers coming inside Luxembourg, sometimes we are not blocking them, no, blocking yes, but monitoring not, because we don't really, it's not really interesting for us at some point. One of the attacks which is really interesting for us, it's all the location tracking going on. Because obviously when you are, I don't know, a state agency or even criminals, you are selling this type of services on Tor, on plenty of different markets. And Gons, please, back. Yeah, so usually we get like something like 150 messages per day targeting so asking for the location of subscribers. So, and as Luxembourg, you know, it's like really a lot of banks and European institutions, so you have plenty of interesting roamers to target. Yeah, gone. So this is like 3 months of just a graph of the number of IDR location requests on my network. And so as you can see, sometimes you have really peaks of it. So you can, okay, you can think that there is an event or the network is getting attacked or there is like a special country, delegation visiting Luxembourg. I don't know, it's like really, it's somehow really interesting just to take a look to the graph to understand after what is going on in the country. But the fact is, when you take a look really at the subscriber level, per day, so I did statistics, but like per operator. So each part, it's one operator. And you see that inside one operator, you have IMSIs, which are like getting almost 90% of the subscriber location tracking request on them. So the top two of the second one, this one is like 76%. The first one, both of them, which are relinked because it's 4148 and 4149, so maybe two SIM cards bought at the same time by the same person. So these people, as you can see, they are really more targeted than all the other subscribers. So it's quite interesting to take a look on what they are doing on the network. And more than that, when you are taking a look to the behavior of who is sending this location tracking to your network, you can take a look to the timestamp. And when you take a look to the timestamp of some attacks, I took one of them, and you can see that at the minute and the second, it's like really precise, like it's the minute 2 and seconds 33, and you get all the location tracking requests at the same time for the same IMSI. So it's like really a machine just asking for the location of this subscriber. So at this point, it's not anymore a human or anything. So you know that this subscriber is getting really tracked by someone. Yeah. So next part, it's now mainly on passive monitoring of other operators. So since we are running this probe, we are also looking at what we can see from other operators, from what they are doing. And one of the things is on the diameter AVPs, you have a session ID to track the session. And usually this session ID contains the diameter identity, which is the identity of your node. Okay, so the HSS or MME. And some integers, 32 bits or 2 integers, and optional values. But by looking at all the statistics, since we are getting a lot of different nodes contacting us, you can really guess like which brand of equipments are contacting you from, I don't know, any network around us. So just by looking at the patterns, you can see that they are not really using or following the RFC, since, I don't know, for example, Huawei is inserting a 0 between the identity and the first int. Yeah, I don't know, Nokia is just following the RFC without any optional value. Ericsson is adding some funky numbers after. So you have plenty of, and this is just an example, but you can get it for all the vendors. The next one is you want to monitor also what operators are doing on their own network. So to do that, you have some really interesting messages, which the name is the reset, like S6A reset message on diameter. And this message is sent when there is like a fault on the HSS. As the HSS, it's your core node handling all your authentication. If this node is down, all the network is down. So you know that when the HSS crashed or it's getting reboot, obviously this message will be sent to all the MMEs to just get back the last information they have on your subscribers. And I was looking for all the reset messages I was getting from other operators, and at some point I saw that one operator was sending me always 89 reset messages from this operator. So I took a look to the timestamps, and I saw that one frontend number 9 at the beginning of January this year was sending me 89 reset messages. A bit later in January, again 89. And after all the front ends of the HSS of this operator sent to me this 89 reset messages. So I can deduct, obviously, that they were trying to upgrade their HSS, and the first time it failed, the second time they succeed, so now they knew that they could upgrade everything, so they did the full upgrade of their nodes. So you can, like that, monitor what other operators are doing on their network. Also, a bit about spoofing. We are looking also to who is trying to spoof our internal network from international. And this, you can clearly see that it's really not happening so often, which is quite good. But you see some operators that are usually doing misconfiguration. So yeah, really not so interesting. But still, the ideal location, you have some spoofing which are done to try to bypass sometime the protection. Also, last thing, it's every time you are doing a request on diameter, all the hops that you are passing through are adding their own identity at the end of the diameter message to tell you, okay, this message I've passed through this node. And by looking at this route record AVPs, you can know from which route took this packet to come to your network. And obviously, normally, if one operator is always contacting you from a specific route, if you see a change on this route, you should be like quite alerted to understand if there is any issue on the diameter network. Last one on the issues that I will speak about today, it's the call spamming. I took like a screenshot of our Splunk instance of the 4 last days, and the count that you see on the right side, it's like the number of calls that we are getting in like 15 minutes ranges. So this means that sometimes operators are just spamming us like with 7,000 calls per within 15 minutes, which is for us, for our network, quite huge because Luxembourg is a small country. So we are trying to get rid of that. And so what we are doing is we are getting all the CDRs, which are the charging logs generated in real time by the switching equipment handling calls on our network. And within a delay that we are reducing, but 5 to 10 minutes, we are getting everything on Splunk and alerting the teams directly to block these numbers. Now, the goal is to do it automatically, but it's still a challenge.
Right. So as you have seen before, we have a framework which is able to monitor our diameter network elements, to decode them and to get data into our Splunk framework. So basically, we have tons and tons of data. And now so as you have seen also, we have many kind of threats, different kind of threats that we need to deal with. So we cannot deal with those threats manually because we have a huge amount of data. We have different kind of threat as well. And then, so our next question is can we detect those threats automatically thanks to advanced data analytics? So I guess everybody recently heard about advanced big data analytics for sure, right? So it's all about how to make sense of the data, how to gain knowledge about the data, about what happened, when it happened, and because of which root causes. So you can gain some descriptive information, you can gain some predictive information from the data. And then, so why now? So the question is, why now? Why it could not happen before? So I guess you have, you would agree with me that's because of thanks to the maturity of the hardware. So now we have more computing power, we have cheaper storage, and also we have a lot of tool, which is very good tool. Like you can see this morning about the graph about Twister, for example. You can see a ton and thousands of nodes. Before we was not able to deal with that. And now, thanks to the advances of the technology, we can deal with that. And also, thanks to the the business strategy. So, I mean, more and more people talk about like data-driven business. So they don't talk about traditional business model anymore. So they want to really deal with, want to have informed decision based on data, based on facts. And why on telecom data? So we have to deal with fraudulent activities like massive SMSs, like massive calls, And also we have to deal with massive amount of data. We are talking about a few hundred gigabytes per day of data. So, but how we do at Post? So first, we put regulation and customer privacy in the first place. So we have to filter as much as possible from the source in order to remove sensitive information if it is possible. And then we anonymize data whenever it is possible. And furthermore, we put in place one auditing mechanism. So it generates report like every morning, reporting who has access to the sensitive data in the previous day. So we can react quickly if something malicious happens. We are able to collect data live from diameters. We are able to collect data from the CDR in batches with a delay of 10 to 15 minutes. And we are, in the course of developing advances methods to predict anomalies. So the anomalies easily linked to security incidences. And also we use some kind of basic unsupervised machine learning like clustering to detect outliers, which are some, many of them are very interesting to take a look to, and they relate to some spoofing. Sorry. So I'm going to very quick to show you two examples of our result. So the first one is how we deal with time series. So as you see earlier, we have seen a very predictable behavior of the traffic, daily traffic. So we can use those data, those past data, to predict what we would expect at the present. So we use so here, for example, as you can see here, we predict for the current week based on the previous data. And so the blue one is the actual data, and the predicted one is the yellow one. And as you can see, they are quite close to each other, meaning that we can predict quite precisely the actual data. So if the actual data deviate far away from the predicted value, then we consider them as one incident, and we should deal with that. And then thanks to these techniques, we are able to detect some real incidents. For example, we have massive call from Congo and from some other countries that I never heard before. So the next one, so here we are not talking about only time series data, but talking about multi-dimensional data. So we talk about number of calls, the frequency of call, the duration, the originating locations, and the entropies in the targeting numbers. And we are using, I was using clustering, simple clustering. And we were able to detect interesting data point over there, which is related to the some massive call frauding. So to sum up, we started this project less than a year ago. It was quite quick, and we was able to go. We have been, gone from zero to be able to observe live traffic and to be able to detect incidents in a quite near real-time manner.
So on more and more, we are integrating like more and more protocols, obviously, because we want to have a focus on everything which is going on the network. So since there is like 10, 20 perimeters on a telecom network, you need as many decoders, as many like probes on your network to get visibility on them.
So with that, I thank you again for your, staying here with us.
Thank you.
Thank you. So it's late, but does anybody have questions? It's nearly the weekend, apparently. Anybody have any questions? Okay. Yep. Sure.
Did you experiment also with deep learning or neural networks or ENNs?
Oh, not yet.
No, not yet.
So that's actually one point I was skipping. So
okay.
We decided to start simple, and already the result is quite encouraging.
So it's not
we don't need sophistication for now, okay. And then in the next step, we will deal with that.
Okay,
Thank you for the question.
Thank you very much. Any more questions? Okay, well, thanks.